Homework 10.1 is a review of Algebra 1 level systems of equations. There are three ways to solve systems of equations. Let's make sure we know all of them. The first way is solving by graphing. And the way this works is, remember what a solution to a system of equations is the x and y values that make both equations true. So we're trying to find an x and a y that when we plug them in here and here, make both the equations true. A thing to remember about graphing is that a graph is all of the x and y coordinates that make an equation true. So if we graph one line and then graph the other line, what we've graphed is all the places that make both lines true, and we just have to find the place that makes both of them true. That will be where they intersect. I'm going to do the harder one here. To be able to graph this, we really want to get it in slope-intercept form. So the first thing to do is solve for y. So we subtract 2x from both sides. For y equals negative 2x plus 8. We divide by 4 on both sides. And remember, dividing, just like multiplying, distributes. And so we get y equals, this gets, both of these terms, because there's a plus, get divided by 4. And so we get 2 divided by 4 is 1/2 x. 8 divided by 4 is 2. On this side, when we subtract x, we get y equals negative x plus 5. And I had to divide by 3 here, so I'll go ahead and divide by 3 to save myself a step. I guess I should have just written 3y here so you're not confused. So we divide by 3. Here there's a 1 in front of the x that we were dividing. Dividing by 3 is the same as multiplying by 1/3. This is negative 1/3 x plus 5/3. Okay, let's graph these. The first one is y equals negative 1/2 x plus 2, has a y-intercept of 2. Slope of negative 1/2. There are two ways to think about a slope. One is that it's going down by a half each time, or the usually easier way to think. Oh, you guys can't see this graph. Hold on. Let's move this. I'm trying to play around with a new thing. So you can either go down by 1/2 each time x goes up by 1, or you can go down by 1 over by 2, which is usually the faster way. Down by 1 over by 2, down by 1 over by 2. And when we go backwards, we're going up by 1, left by 2. So this is the first line. Looks like this. Cool. There's our first line. Okay. Our second line is negative 1/3 x plus 5/3. Now, this is a little tricky. 5/3 is 3 goes into 5 one time. That would be 3/3, and then there's 2/3 left over, so it's 1 and 2/3. So the y-intercept is going to be at 1 and 2/3. And this is one of those times when it's actually easier to think of the slope as going down by 1/3 each time. So we're at 1 and 2/3. When we go down by 1/3, we'll be at 1 and 1/3. When we go down by 1/3, we'll be at 1. And then from here, you can go down by 1 over by 3, down by 1 over by 3. And so sometimes it is useful to think about a slope as not being how much down and how much over, but also just being, hey, every time x goes up by 1, you go down by 1/3. So you're at 2/3, 1/3, no thirds. So this is our, these are our two lines, and the solution is right here. The solution is x equals 2, y equals 1. And that's how we write it, is x equals 2, y equals 1. We could also write it as a point, 2, 1, because when you write a point, it's automatically x and then y. And so both of these are fine solutions to this system of equations. Again, what it means is that if you plug in 2 and 1 into either one of these equations, it'll become true. 2 plus 3 times 1 is 5. 2 times 2 plus 4 times 1 equals 8. When x is 2 and y is 1, both equations are true. All right. Another method, substitution. So the way substitution works is you have to know what one of the variables is equal to. For instance, in this first one, we know that y equals negative x. And the way it works is we put in negative x in the other equation where y is. It's called substituting. And the idea behind it is, instead of having an equation with x's and y's, you end up with one equation with just x's. I'm going to do the hardest one here. This hardest one, we don't know what any of the variables is. You can solve for any variable you want, but there's usually one variable that's easiest to solve for. If you notice, there's just a single x here. And so we can solve for x very easily by moving the 2y to the other side. X equals negative 2y plus 2. We just subtracted 2y on both sides. And once you know that x is negative 2y plus 2, we're going to substitute in for what x is. X is negative 2y plus 2. So in the other equation where there's an x, we're going to put negative 2y plus 2. 2 times negative 2y plus 2, that's what x is, plus 2y equals 4. Notice this equation says exactly the same thing it said before. 2x plus 2y equals 4. 2x plus 2y equals 4. I just substituted what this was. And now it's an equation with just one variable, and we can solve it using normal algebraic methods. We're going to distribute negative 4y plus 4 plus 2y equals 4. Subtract 4 on both sides. Combine like terms. Negative 2y equals, when I subtract 4 on both sides, I get 0. And so y equals 0 by dividing by negative 2. That's part of the solution, but it is not the whole solution. I also need to know what the x value is. So I take my y value, and now I substitute it back in. Again, I can substitute it anywhere and solve for x, but the easiest place is the place where we had x equals. X equals negative 2, y is 0, plus 2. Negative 2 times 0 is 0. 0 plus 2 is 2, so x equals 2. So my solution is y equals 0 and x equals 2, or again, I could write it as a point. The x goes first and then the y, so 2, 0 is also a possible solution. Either one of these is fine. On the back, we've got substitution, elimination. The way elimination works is it takes the fact that if you have two equations that are true, I'm just making up random numbers here, 1 plus 3 equals 4, 5 minus 1 equals 4, they don't have to equal the same thing. If you add the two equations together, it will still be a true equation. And this makes sense because you have something equals something, something equals something. You add them together, you've got two things that equal each other. And so, for instance, if I add these together, I get 6 plus 2 equals 8, still a true equation. And we make use of this when you'll notice here that if we added these two equations together, negative y plus y would be 0. And so we won't have any y's left over, we'll just have x's. We eliminate the y's because the y's won't be there anymore. So we have these two true equations, we just add them together. X plus 2x is 3x, negative y plus y is 0, we're not going to write it. 7 plus 5 is 12, and so x is 4. Once you find what x is, you do need to go back and substitute to find what y is. You're allowed to substitute in either one of these equations to figure out what the y is. I usually look to see what's easier. 4 minus y equals 7 looks harder than 2 times 4 plus y equals 5 to me because of the negatives. So I'm just going to put in 4 for x right here. X is 4. So 2 times 4 plus y equals 5. So y is negative 3. That comes from subtracting 8 on both sides. So my solution is 4, negative 3, or I could put x equals 4, y equals negative 3. Either one of these is fine. I hope that helps. Hopefully we remember our Algebra 1 stuff. Good luck on the rest of your homework.